SciPAD, page 165, looking at this very central and important idea, rotational inertia. Symbol I, measured in kg meters squared, is a measure of an object's resistance to the change in rotational motion. Just like linear inertia, mass, resistance to change, rotational inertia is exactly the same. It's dependent on the mass of the object and how the mass is distributed. And so here's a whole bunch of equations. Essentially, the one we use is I equals mr squared, or I equals a half mr squared. They tend to be the two, and if you expect to use another one, they'll explain that or give that to you. So the first one, say, describe the concept of rotational inertia. Well, basically, it's a resistance to an object's change in motion. So I'll take that straight out of SciPAD's answers. A large I means it's hard to get it started, or it's hard to make it stop. State the quantities that affect rotational inertia. Well, we can see that straight away from the equation above, that it's going to be mass and the distance mass is from the center of rotation. So if you've got a thin ring because all the mass is on the outside, or you have a solid ring and they both have the same mass, this one's going to have a higher rotational inertia because more of that mass is further away from the center, even though they have the same total mass. It's to do with mass and the distribution of mass. And actually the distribution of mass is actually more important because you'll see that it's an r squared rather than just linear. C, two objects have identical torque acting on them. Object A has a larger rotational inertia than object B. Discuss how that will affect. Well, we're going to use torque equals I alpha, and for the same torque, the larger rotational inertia will have less angular acceleration. So to take it straight out of SciPAD's answers, the larger the I will experience less rotational acceleration. D, explain how the rotational inertia of a thick ring would change if its mass density is doubled, but its distribution is held constant. Well, we know that torque equals I alpha, and we know that I approximates mr squared, and so if you increase the mass yet leave the distribution of mass the same, and it uses the word doubled. In physics, whenever they tell you how much it's changed by, they expect that in the answer. So if mass is doubled, because it's linear, it should also be doubled. D double I, if mass is held constant but both radii are doubled. So okay, so we're talking about a thick ring. I kind of missed that start time. So a thick ring from up here is going to be using this equation. It's still basically the same. And so if we are saying I equals m r1 plus r2 individually squared, yep. And so if these go up, then I is going to go up. Now again, they've used the word double, and if you double something and square it, 2 squared is going to be 4. So it's going to be bigger by a factor of 4. Okay, last question. E, a solid rod is rotated along its vertical axis and then along its horizontal axis. So you can think of a rod that way. This is the same rod that way, and I'm assuming it's going to go around that way, and then it's going to go around that way. Which one is going to be would have the least rotational inertia? Clearly it's going to be this one, because the radius here is really, really small. R is small, so I is small. Here the radius is large, so I is large. That's the end of that page.